In this video, we're going to prove the following fact. If A is congruent to B, and A is also congruent to C, except the congruency is with different mods, mod N1 and mod N2. Then you kind of have the transitive property. If A is congruent to B, and the transitive property. If B is congruent to A, and A is in turn congruent to C, then you have B is congruent to C with a new mod. That mod N is the GCD of N1 and N2. Now, how I see this is we have some information. This is how I see most of my proofs. I try to go by definitions, because definitions usually help. So we're given this piece of information. Let's number them. We're given this piece of information. And we want to show this piece of information, and we definitely have this piece of information. So this is the only one that we don't really have. We need to show that. In fact, let's call this 3 and 4. So we have 1, 2, and 3. Now, if you like seeing mathematical proofs, I suggest that you subscribe to my channel, as that's all we do on this channel. Pick any one of my videos, and I assure you that it's going to be a mathematical proof. Now, back to the proof. Statement 1 says that N1 divides A minus B. And statement 2 says that N2 divides A minus C. And statement 3 says that if N is the GCD of N1 and N2, that implies N divides N1 and N divides N2, which is really good, because if N divides N1, we have that right here, and N1 in turn divides A minus B, that implies that N divides A minus B. And if N divides N2, and we have that right here, and N2 divides A minus C, that implies that N divides A minus C. So let me write A minus C. Okay, now this implies that N divides. Now I want the A's to cancel, because what I want to show is equivalent to N divides B minus C. That's what I want to show. So I'm going to say N divides this minus that. This minus that. And most definitely the A's cancel out, and what's left over is B minus A. But this implies that B is congruent to A mod N. Now let's see what we wanted to show. Sorry. This difference turns out to be B minus C. So B is congruent to C mod N. But possibly they didn't ask that. They could have asked that C is congruent to B. And then I would have said that that implies that C is congruent to B mod N. But they didn't ask that, so let's not do more. Remember, if you do more than you need to do, and the more has an error in it, then your proof is invalid. Proof has an error in it. This completes the proof because given the givens, I was able to prove that in fact B is congruent to C modulo N, where N was the GCD of N1 and N2. Now, question is, did N have to be the GCD of N1 and N2? Could we have gotten away with N just being a common divisor of N1 and N2? A weaker statement. In the comment section, or state what you think. Could we have gotten away with N being just any old common divisor of N1 and N2? And if you think we could not have gotten away with this weaker statement, state where in the proof it goes bad if we don't allow N to be the greatest of all the common divisors. See you guys in the next video. Subscribe to my channel. Leave a comment. Don't forget, watch and learn.